Okay, so factoring by GCF. So we're going to review GCF stands for greatest common factor. So you are going to need to be able to flip back and forth to your factor squares in order to do this, unless you want to, waste your time and really have to look up values. I suggest having your factor squares readily available. That's why they are in your notebooks. So in order to factor by GCF, so we're going to have a polynomial. We're going to have something plus something plus something plus something, or minus. And we're going to factor it. So we're undoing what we just did. We are undistributing. We are taking the answer, the problem, and we are undistributing. We're finding what do all of the terms have in common, and we're moving that outside of parentheses. So we're unfactoring it. So when we factor these, when we talk about this, there are a few things that we need to make sure before we even start. So the first thing we need to make sure before we even start is write in standard form. It could already be in standard form, and that's fine, but it might not be in standard form. So we need to rewrite, if necessary, in standard form. So you're going to have a polynomial. You need to make sure that that polynomial is written in standard form. We're going to find the GCF, greatest common factor, of all the terms. So if you have 3 terms, it's a trinomial. You need to look at all 3 terms and say, what can each term be divided by that's in common? So if you had 2x, 4y, and 6z, they're all even, right? So they could all be divided by 2. So you're looking to see what do they all have in common. Sometimes they only have numbers in common. Sometimes they have numbers and variables in common. You have to look and see what do they all have in common. Then you're going to divide each term by the GCF, which is the undistribute. When you distribute, you multiply everything. This time we're going to divide everything. We are undistributing. And then last but not least, we're going to write the solution. So we're factoring by GCF. So we are looking at, we're making sure that it's in standard form, exponents in order from greatest to least, right? We're finding the GCF of all of the terms. So that's where your factor squares are going to come in handy. If it's, the coefficients are 56, 36, and 12, and you look at your factor squares at the square for 56, the square for 36, and the square for 12, you can easily see what they have in common without having to do a factor tree and figure it all out. So writing the solution, the GCF goes outside the parentheses. The quotients, what are quotients? What does quotient mean? Anna?
I don't know the meaning of quotient, but aren't they the numbers inside the parentheses?
Well, they are, but what does quotient mean? Doesn't mean numbers inside parentheses. What does it mean, Lily? The answer to a division problem, because we're dividing, right? So the quotients, the answer, what you get is your solution when you divide by the GCF. The quotients go inside the parentheses. All right, let's practice. 3x squared plus 12, or no, that's to the third, please. 3x to the third plus 12x squared plus 9. 3x squared, 3x to the third plus 12x squared plus 9. Let's give it an x. 3x to the third plus 12x squared plus 9x. Pretty simple values, 3, 12, and 9. But in case you don't know them, I'm going to look at 3, I'm going to look at 12, and I'm going to look at 9. What is the largest factor that 3, 12, and 9 have in common? What do they all share? What number is in each box? Evan? 3. So our GCF, is our GCF just 3? Is there anything else that they share? Ariana, what else do they share? They also share an x. So I'm going to write this out so that you see it, because these are notes, right? I'm going to take 3x to the third plus 12x squared plus 9x, and I'm going to divide it by 3x. Three x to the third divided by 3x, what's left over? 3x to the third divided by 3x. What's 3 divided by 3? 1. What's x to the third divided by x? X squared. Right? Do you remember your rules for division? What is it? Divide the coefficients. Subtract the exponents. All right. Now I'm moving on. 12x squared divided by 3x. 12x squared divided by 3x. So it's 12 plus 3. Or no. 12 divided by 3. Positive. And x squared divided by x is just regular old x. Then I move on. 9x divided by 3x. 9 divided by 3 is
3.
So plus 3. X divided by x is nothing. Disappears, right? They cancel out. So my solution, write the solution. The GCF goes outside the parentheses. So my GCF was 3x. And the quotients go inside the parentheses. So my quotients are 1x squared plus 4x plus 3. Here's the trick. Negative 8y to the third plus, no, minus 10y. If they are all negative, the GCF is negative. If they are all negative, if all of the terms are negative, the GCF is negative, which is counterintuitive because negative numbers are smaller than positive numbers. Do you agree? And this is called the greatest common factor, meaning it should be the biggest number they have in common. And right now, 8 and 10 can be both divided by 2. So the GCF for this problem is negative 2. And I get it. 2 is greater than 2. It's called a GCF. It should be greatest common factor. However, if they're all negative, the GCF needs to be negative because you're factoring out that negative value. But the GCF is not just 2. What is the GCF?
Negative 2y.
Negative 2y. Because they both share a y variable. Ready for practice? Okie dokie.
So if only one term's negative, the GCF isn't negative?
Correct. All right, so the first one, 36f plus 18f squared minus 3. I have a problem with it. My issue with that trinomial is that it is not written correctly. Right? 36f plus 18f squared minus 3. I need to rewrite it so that it's in standard form. Malachi asked a good question. He said, okay, wait, so there's a negative, but they all have to be negative. So this GCF of this trinomial will be positive. The only way your GCF is negative is if all of the values, all of the terms are negative. So, raise your hand who can tell me what is this in standard form? Standard form, Sam. Perfect. 18f squared plus 36f minus 3. Excellent. I'm going to look at 18, 36, and 3 and see what do they all have in common. What factor do they all have in common? 3. Are there any variables in common? No, because this last term is constant. It has no variable value, so they cannot all share variables. So we're going to divide 18f squared plus 36f minus 3 divided by 3. And my solution, what's 18 divided by 3? 6 f squared. What's 36 f divided by 3?
12.
Positive
That's
12f. And negative 3 divided by 3 is
negative 1.
negative 1. That's my solution. Is it?
No.
Nope, because now I have to take this to what? 3. 6f squared plus 12f minus 1. All right, go on to the next one. See if you can do the next one. See if you can start it. Negative 42f, no, x to the fifth. Negative 42x to the fifth minus 96x to the fourth minus 22x. So look at your factor squares. Oh, before we look at our factor squares, is it written in standard form?
Yeah.
Yes, so we're good there. Now we're looking for the GCF. We're looking, what do 42, 96, and 22 all share? 42, 96, and 22, what do they all share?
2.
Greatest common factor is
Negative 2.
why negative 2?
Because they're all negatives.
Because they are all
And it's negative 2x.
negative terms. So the GCF, my coefficient is negative 2. Do they all share a variable? X. Negative 42 x to the fifth minus 96 x to the fourth minus 22x divided by negative 2x. Negative 42x to the fifth divided by negative 2x. Positive 21 what? X to the fourth. Negative 96x to the fourth divided by negative 2x. Positive?
Yeah.
48 x to the third. Negative 22x divided by negative 2x is positive 11. Is that my solution? No, you have to remember negative 2x is my greatest common factor. 21x to the fourth plus 48x to the third plus 11. Yes, sir.
In the future, are we going to be doing this backwards and going from the end from the solution back to the original problem?
I mean, you may. You may have to eventually, have a mixture of going back and forth. In this unit, no, we are only factoring. We are not distributing. All right, let's try this one. Here's my first issue with this. Is it written in standard form? Let's see. That's 4 plus 5 is 9. 5 plus 2 is... Yes, it's in standard form. All right, so can you look on your factor squares and tell me negative 230, what are the factors of that?
Not really.
Why not?
Because it's not on there.
It's not on there. So we have to actually, when they're too big and they're not on our factor squares, sorry, they only go to so high, we have to factor it. We have to use our prime factorization tools from pre-algebra and before. So if I look, I'm going to take out a negative 1. Then I'm going to factor what factors of 230. What should I go with? It ends in a 0, so what should I divide by?
2.
I divide by 10. Could you divide by 2? Sure. What do you know about 10 What times what is 10? 2 times 5. And those are both prime, so I'll stop there and circle them. What do you know about 23? It's also prime. So the factors of 230, or negative 230, I'm going to write them down, are negative 1 times 2 times 5 times 23. Now let's factor 136. It's not on our factor squares. So what times what is 136? It's even, so let's start there. What can I divide by? 2. 136 divided by 2 is 68. 2 is prime, so I can circle it. I stop there. What do you know about 68? What times what? 2 and 34. 2 is prime. What do you know about 34? Can we divide it again by 2 because it's even? 34 divided by 2 is 17. 2 is prime. So is 17. So let's write down my factors of 136. 2 times 2 times 2 times 17.
So 2.
Now to look for greatest common factor, we look to see what do they share. And they only share a 2. If they shared a 2 and a 5, the greatest common factor would be 2 times 5 is 10. But they don't share a 2 and a 5. They only share a 2. So what is the greatest common factor of these two terms?
2.
2, but I'm not done yet. How many x's do they share?
4.
X to the 4th. How many y's do they share?
2.
Y squared. Don't forget about your variables. It's going to be one of the more common mistakes that we make is you forget about your variables. All right, so let's divide negative 230 x to the 4th y to the 5th plus 136 x to the 5th y squared divided by 2x to the 4th y squared. Negative 230 x to the 4th y to the 5th divided by 2x to the 4th y squared. Again, you guys, the rules are just divide your coefficients, subtract your exponents. What is negative 230 divided by 2?
Negative 115.
Negative 115. What's x to the 4th divided by x to the 4th? Nothing, it disappears. What's y to the 5th divided by y squared? What? Y to the 3rd? What's 136 divided by 2? Positive?
Yes.
68? What's x to the 5th divided by x to the 4th? Just regular old x.
And the
Y squared cancels out. This is in standard form. Why is this in standard form?
There's the y has more exponent.
Because the y has a greater exponent than the x, even though it's not in alphabetical order, right? Is this my answer? No, my solution is 2x to the 4th y squared, because that's my greatest common factor, parentheses, negative 115 y to the 3rd plus 68x. Greatest common factor. We are undistributing. We're taking the solution to our distribution problem and we're finding the problem. We're taking the greatest common factor out of each term. if you somehow lose your factor squares, this is what you have to do for each problem,
Oh no. I'm not good at that.
right?